All right, our last lesson of chapter 5 is lesson 5, and it's on double angle identities. So just like how sum and difference identities don't quite work out the way we want them to, double angle identities are the same. So sine of 2 theta is not 2 times sine theta. And we know this, for example, because if I take sine 60, just for example, compared to 2 times sine 30, well, sine 60 is square root of 3 over 2. Sine 30 is 1/2, and this would equal 1. And we know that the sine of 60 does not equal 1. So it just doesn't quite work out that way. We have different identities to figure out what sine of 2 theta is, what cosine of 2 theta is, and tangent 2 theta. We actually have 3 different ways to find cosine 2 theta. We're actually going to use a instead of theta, but the letter itself doesn't make a difference. Cosine 2a is the same thing as cosine squared minus sine squared. So this is different than the trig identity because cosine squared plus sine squared is 1. But if you subtract them, you get the cosine of the double angle. Another way you can do cosine 2a is 1 minus 2 sine squared. And the last way is to do 2 cosine squared minus 1. And these are all just different forms of the same thing. All right, only one way to find sine of the double angle, and it is 2 times sine times cosine. Tangent, of course, tangent always has a complicated formula. It's 2 tangent A over 1 minus tangent squared. And those are our formulas. And we're going to keep referring back to them throughout the examples here. So make sure that you're ready to flip back and forth. Okay. So given that cosine theta is 3/5 and sine theta is less than 0, find sine 2 theta, cosine 2 theta, and tangent 2 theta. Okay, so in order to find sine 2 theta, I need to know the sine of theta and the cosine of theta. Now, I already know the cosine, but the way that I'm going to find the sine is to draw a triangle. Draw a triangle. Now, why do they tell us that sine is less than theta? What they're doing is they are telling us what quadrant this triangle is going to be in. So in order to have a positive cosine and a negative sine, that means I have positive x values, negative y values. If you think about your unit circle, that means I'm in quadrant 4. Quadrant 4. So here's theta. And we know that the cosine is 3/5. So adjacent over hypotenuse. This is a nice 3, 4, 5 triangle. Just make sure that you label that side as -4 because we have the negative y value, the y or the y direction. So what that means is that sine theta is -4/5. So once I have that, now I'm just going to plug everything in to my formula right here. So sine 2 theta is 2 sine theta times cosine theta. Well, 2 times, we just found the sine over here, so -4/5 times cosine theta, which was given to us, is 3/5. So sine 2 theta, multiply across, 2 times 4 is 8 times 3, so I have -24 over 25. All right, let's try cosine 2 theta. We have lots of ways of figuring out what cosine 2 theta is. They will all get you to the same answer. It really doesn't matter. And especially since we already now know both cosine and sine, we can choose whichever one we want. I'll just do the first one just because it's the first one on the list. So cosine 2 theta is going to be cosine squared minus sine squared. So cosine was, again, what was given to us. So I have 3/5 squared minus sine theta is -4/5 squared. 3/5 squared is 9/25. 4/5 squared is 16/25. And then we do the subtraction, -7/25. All right, last one, tangent to theta. Two tangent theta over 1 minus tangent squared theta. So first of all, I need to know what tangent theta is, which is opposite over adjacent. And now I'm going to plug everything in. So I have 2 times -4/3 over 1 minus -4/3 squared. Oops, I'm sorry. So on top, that gives me -8/3. On the bottom, I have 1 minus 16/9. This is really 9/9 if I'm going to get a common denominator. And 9/9 minus 16/9 is -7/9. And dividing fractions is the same as multiplying by the reciprocal. So I'm going to have -8/3 times -9/7. Which, what does that give me? That gives me 72 over 21, which I can simplify to 24 over 7. So tangent to theta is 24 over 7. Now, this was like a really long way to do it. Tangent with the tangent formula and doing all these fractions and everything. Another way is that if I know sine and cosine, I can just do sine divided by cosine and get tangent. So if I just did -24 over 25 divided by negative 7 over 25, change that to a multiplication problem and simplified it, I would also get 24 over 7 for the tangent. So that would be an even better way to do the problem. I just wanted to show one complete run through of using that tangent identity. All right, example 2. We're going backwards for this one because in this one now we are given the value of cosine 2 theta, and we have to go back to theta. Okay, so we're going to go up to our cosine identities. And again, it doesn't matter which one we pick. Well, we can't pick this one because we can't solve for both cosine and sine at the same time. We're going to have to pick one of these. And again, it doesn't matter which one we choose. I'm going to choose this bottom one. So what we know is that cosine 2 theta equals 2 cosine squared minus 1. And we know that cosine 2 theta is 4/5. So what we're going to do now is solve for cosine theta. So I'm going to add 1 to both sides. And when I add 1, I'm going to think of this as 5/5. So this gives me 9/5. Now I'm going to divide by 2. And another way to think about dividing by 2 is that you're really multiplying by 1/2. So 9/5 divided by 2 becomes 9/10. And now we take the square root, which gives me plus or minus 3 over the square root of 10. Now, I have to figure out whether I want the positive version or the negative version, and that's where this piece of information comes in right here. This right here tells me that theta is in quadrant 2. If I'm between pi over 2 and pi, that means that the angle is in quadrant 2. And in quadrant 2, cosine is negative. So we have negative 3 over the square root of 10. And you might be thinking, wait, don't I have to rationalize the denominator? Yes, we do have to rationalize the denominator. However, just for the time being, I'm going to leave it like this because what we're going to do now is create a triangle based off this to find the other trig functions instead of going through all these identities every time. So I'm going to make my triangle in quadrant 2. Cosine is negative 3 over the square root of 10. This is not a nice Pythagorean triple by any means. We need to solve for this distance here. Y squared plus negative 3 squared equals the square root of 10 squared. Y squared plus 9 equals 10. So y is going to equal 1. And now that I have all 3 sides of the triangle, we can just go through SOHCAHTOA and get all 6 trig functions. So sine is going to be opposite over hypotenuse. Rationalizing the denominator, we would have square root of 10 over 10. Cosine, adjacent over hypotenuse, which when we rationalize the denominator, we get negative 3 square root of 10 over 10. Tangent, opposite over adjacent, negative 1/3. Cosecant, hypotenuse over opposite, square root of 10 over 1 is just square root of 10. Secant is hypotenuse over adjacent, so square root of 10 over negative 3. Cotangent, adjacent over opposite, so we just have negative 3. So there's my final answers there. Phew, that was a lot. Feel free to pause the video right now, just take a 2-minute breather, and when you're ready to, continue the video and turn to the next page to finish up the last couple of examples. I promise they are not as involved as these ones. All right, on page 23, we're going to continue with these last couple of examples. We're not going to do example 5, so you can just cross that off. So just these 3 to go. One of these is verifying an identity. So bringing back some of our earlier lessons into this one. So I want to try to make the left side match the right side or vice versa. You could do it either way. I'm going to try to make the left side match the right side. And one of our strategies is to turn everything in terms of sines and cosines. So cotangent is really cosine over sine. And sine 2x, even though it is a sine, it has that 2 in there. So we're going to use the identity for sine 2x. So let's quickly flip back and see what that is. So sine 2x or 2a is just 2 times sine times cosine. So I'm going to rewrite it like that. So we have 2 times sine times cosine. Now, when I write it like this, think of this as all over 1. And when we do that, that means our sines are going to cancel out. And we're left with 2. And cosine times cosine gives me cosine squared. Okay, so how does that give me 1 plus 2 or cosine 2x? Well, let's flip back to our identities again and see if we can see why this is going to work out. All right, I want you to look at this identity right here. Cosine 2a is equal to 2 cosine squared minus 1. If I rearrange this and move the 1 over to the other side, what that means is that cosine 2a, plus 1, does in fact equal 2 cosine squared, which is what we have. We have 2 cosine squared, and we want to show that it's equal to 2 cosine 2a plus 1. So this does in fact equal 1 plus cosine 2x. And we're done. All right, last couple here. So for these ones, this is trying to get you to recognize what the different identities are. So if I have cosine squared minus sine squared, that's this one right here, cosine squared minus sine squared. So this is equal to the cosine of the double angle. So let me just rewrite that. So cosine 2a equals cosine squared minus sine squared. Now, in this case, a equals 7x. So this whole thing right here is the cosine of 2 times 7x, which just simplifies to cosine 14x. And that's it. That's as much as we can simplify it. All right, last one. Sine 15 times cosine 15. Let's flip back to our identities, to Do I have anything that has both sine and cosine being multiplied together? I do. I have 2 times sine times cosine. Now, let me just write that down on the other page so we can refer to it. Now, you might be looking at that and saying, wait, that doesn't have a 2 in front of it. That's true. So let's kind of manipulate this a little bit here. If I just have sine and cosine, this is the same thing. So I'm going to basically multiply both sides by 1/2 to get rid of that 2. Okay, so in this case, A is 15, which means this is 1/2 sine of 2 times 15, which gives us 1/2 times the sine of 30, which we do know. We know the sine of 30. The sine of 30 is 1/2, and half of a half is a fourth. So this one's definitely kind of sneaky. You have to manipulate that identity a little bit to make it match what you want it to be. All right, that is it. That's your last lesson of this semester. Come with your questions. We'll do lots of practice when we see you in class soon.